Hi everyone, I'm Luis Lu. So today we'll be presenting functions, and I will be giving out some brief introductions for the function. And today's main question is, what is a function? Also, this video is created for my personal project, and if you feel this is useful, please use the feedback sheet I will be sending out later on Google Form. So firstly, by definition, what is a function? And a function is a mapping between two number sets. For those who don't know what a set means a collection of elements. An element can be literally anything. It can be a number or also can be an object. For example, a number can be also an integer or imaginary numbers. And objects can be a triangle or a computer. And it basically means the relationship. A mapping basically means a relationship between two number sets. The relationship can be injective, bijective. Basically means the relationship between the domain and the range, which I will be further explained in next few slides. And by variables, a function is defined as a relationship between one variable with another variable. And but be careful, the one variable in here is belonging the domain sets. And another variable here is belonging the range sets. So it's not not describing the relation between an x to another x. This basically means this. And so geometrically, it's basically a misunderstanding by most beginner of the functions. Is the function a line? So there are two graphs below, and you can pause there to have to think which one is actually a function. Okay, so for the answer, the first one is a function. And to do this, so for this function, it can be described as f of x equals to x. And basically, it's just y equals to x. And for next one, we could. So how can we know is this a function? We could do a method called verification line. So it's basically just plugging a line that is vertical to the x-axis and to see if the function or the line on the graph is passing through it just one time or several times. For the first one, it's only intersect at one point, but for the next circle, it's intersect at two distinct points. This means there are more than one value for y, for one certain 2y, for one certain x value. Basically, it's not what the function wants. The function can be a parable as there are two x value for a single y, but it cannot have two y value for a single x. And also some verification on algebraically. So as I said before, an input cannot have more than one output, which means for x, there cannot have more than one y. But for one output, there can be more input. As a parable I gave before, there are two x value for a single y value. And geometrically, there can only exist one intersection on the verification line. Is based on this theory that there can be only one input for one output. And so for algebra, we could check if there is only exist one y value with one x value, and we just plug in values to see if there's exist 1 or 2. And here are some brief examples below. You could post here to see if if they have only exist one value. Oh, okay. If there's more than, so as a result, the first one is a function, and the second one is actually not a function. Because if we take off the exponent as a 2, we will get y equals to the which means as we open this, we could have multiple y values. Linear functions. Algebraically, a linear function have one independent variable and one dependent variable. And furthermore, the changing rates, which is a slope, is a constant number throughout the domain of the function. The function can be represented as a form f of x equals to mx plus b, and where m represents the slope and b represents the y-intercepts. So geometrically, as shown on the two graphs below, the linear function can be represented as a line, and it has a constant changing rate. So as it's having the constant changing rate, it's a line. And by, for example, f of x equals to 3x minus 7, or fxx equals to x plus 2, where 3 is the changing rate and 1 is a changing rate, and negative 7 is the y-intercept, and 2 is the y-intercept. We could get the y-intercept through plugging x equals to 0, and we could easily recheck it as 0 minus 7 and 0 minus 2, which have been shown on the graph at the right. Furthermore, for there are some practices. Can you please identify the linear functions I've provided below? There are 5, and also some by its graph. Okay, I feel if you're already done, you could check it. The first one, by on its algebra, it's a linear function, and second one is also a linear function, but not the third one. Third one is actually a quadratic function, and it's the fourth one is also not a linear function, but the fifth one is a linear function. As for the first one, the changing rate is 7, and the intercept is on 3, and the second one, the changing rate is 1, but also the intercept is on negative 100. And for the third one, it's actually the parable. So if we could get multiple x values for certain y values. So if we plug in negative 2 for x and 2 for the x, we could see that they have the same y values. And for the fourth one, it basically showing that it's a 2 times x negative 1's exponent at the right, and plus 1 is not where x should equals to x should have 1 as an exponent. It's a negative 1, so it's not a linear function. And for the fifth one, it is a linear function, as it's basically giving us x times 1 over 7 and plus 14, where x do have 1 as an exponent. Yeah, so for the belowing, there are also 5 graphs. You can check which one are linear functions. So for the first one, it's actually not a parabola, but also not a line, as a linear function should be a line as presented on the graphs. So it's not. And for the second one, it's also not, as it's a parabola. But the third one, it's actually a line, as it's having the changing rate throughout the whole domains. And for the fourth one, it's also a line, so it's a linear function. And for the fifth one, it's a reciprocal functions as as the same with the fourth one on the algebra. So it's not a linear function. And lastly, the quadratic function is actually being built up to a linear function, as in the linear function, the highest exponent of the x, which is the input, should be 1, but in the quadratic function, it can be 2. So there will be multiple input value to get a certain output values. So same as the linear function, the quadratic function also have one independent variable and one dependent variables, as it's on the plane. So the changing rate is also not the same throughout the whole functions. As shown below, it's a parabola. If you find the changing rate here, draw a line here, or draw a line here, you could easily see that they have the different slope of the line, and which the slope can be further developed on derivatives. And the quadratic function can be expressed in the form f of x equal to ax square 2 plus bx plus c. Yeah, and that's all for today on the basic. Hope you have a basic understanding for what the function is look like and some example of the functions as linear function and quadratic